Hello Matadors, we're going to try this for the first time, my first video. Woo! We'll see if everything gets working. Just a quick recap. I wanted to thank you guys for being so patient with me. I know it's been hard having subs and me not being there, but I hope you're doing okay. I wanted to remind you really quickly about what we've been over. I did some notes with you the first day, and then Ms. Castillo finished the second side, which talks about functions. You did a couple of worksheets that look similar to this one, in addition to something about a rodeo, and I don't really remember the names of the other ones, but you should have done 2 or 3 worksheets on this, just practicing order of operations, simplifying, multiplying, adding, simplifying in common like terms, combining like terms. Then I also asked you to watch a video on domain and range. You did a foldable on Dixie and Royd, which I had the story all wrong, so I'll have to retell it to you. And then today you guys did stations. So you wrote down some of these notes, some of these examples, and then you were able to do some on your own. So today what we're going to do is we're going to shift gears a little bit, and we're going to start talking about function notation. Function notation is it's a way of saying the value of f at x, or simply f of x. Okay, so I'm going to give you some notes. You're going to follow along with me, and then you're going to have an assignment yourself. My paper might look a little bit different than yours because I'm going to edit yours to save space. But function notation is just a way of representing functions algebraically. Function notation makes it easy to recognize the independent and dependent variables in an equation, which we talked a lot about independent and dependent variables. The function, when you see this symbol, f of x, it doesn't mean f times x. It just means the value of f at x, or the way we like to say it is f of x. Okay, please remember that it does not mean to multiply. What you're going to do is you're going to plug in whatever value you have for x into your equation. So for example, if you have f of x is equal to 2x minus 3, find f of negative 2. So wherever you see an x, you're going to plug it in with a negative 2. So instead of this x here, you're going to put that negative 2 inside parentheses, and then you're going to simplify. So what is 2 times negative 2? Negative 4. And negative 4 minus 3 is equal to negative 4, negative 5, negative 6, negative 7. So this means that f of negative 2 is equal to negative 7. Since remember, this is your x and this is your y, your ordered pair would be negative 2, negative 7. Okay, so let's try that again. The process of calculating the value of a function at a specific point is called evaluating a function. So we're going to evaluate the function f of x equals 2x minus 3 at f of 7. So again, I'm just going to rewrite 2x minus 3. Wherever I see an x, you're going to substitute in the value 7. You always work from left to right. What is 2 times 7? 14 minus 3 is 14, 13, 12, 11. So 14 minus 3 is 11. So that means that f of 7 is equal to 11. Or in other words, the ordered pair for this function is 7 and 11. The input is 7 and the output is 11. Okay, let's go ahead and try f of negative 4. Since I'm evaluating the function 2x minus 3 when x is equal to negative 4, I'm going to rewrite the function 2x minus 3. Wherever I see an x, I'm going to plug in negative 4. What is 2 times negative 4? Negative 8. Negative 8 minus 3 is, hold on, sorry. Negative a minus 3 is 8, 9, 10, 11. It's two negative numbers, so you're combining them. So this means that f of negative 4 is negative 11. Your input is negative 4 and your output is negative 11. So using the three examples that I just gave you, I want you to try letter D, E, and F. The function has changed to k of x. K of x is negative 7x plus 1. So I'm going to give you a few seconds. I'm going to pause it, let you work on it. You pause the video as well, and then I'm going to show you the answers. Ready? Go. A negative times a negative is a positive 7. So 7 plus 1 is 8. That's saying that when my input is negative 1, the output is a positive 8. Plug in a 5 wherever you see an x. What is negative 7 times 5 gives you negative 30, plus 1 gives you negative 29. So your ordered pair should be when x is equal to 5, y is equal to negative 29. Were you able to get all of them right? I hope so. We're going to move on to the next example. This actually has a squared, so it has an exponent. You know, when you have exponents, it means you multiply that number by itself twice. So h of negative 3 means that for the function x squared minus 3x plus 5, I'm going to plug in a negative 3 wherever I see an x. In this case, there's two x's, so I'm going to plug in negative 3 twice. What's negative 3 squared? I'm just going to continue down here, okay? Pretend this isn't there. Negative 3 squared is negative 3 times negative 3, which gives me a positive 9. A negative 3 times a negative 2 is a positive 6. What is 9 plus 6? 15 plus 5 is 20. So this is saying that the function h of x equals x squared minus 3x plus 5 at x is equal to negative 3 is equal to 20. Okay, your turn. I want you to try B. So the final answer was h of 5 is equal to 15. Here's your ordered pair. Did you get that one right? If you did, you're starting to get the hang of this. Yay! Okay, for this next question, it's going to be asking you to fill out the table of values. So we're going to plug in negative 2 into f of x equals 5x minus 3. We're going to plug in negative 1 wherever we see an x for that function. We're going to plug in 0 for 5x minus 3, 1 wherever we see an x, 2 and 3, and so on. Okay? So I'm going to show you slowly the first one, and then I'm going to go a little bit faster. So that is my function, and I'm trying to find f of negative 2. That means wherever I see an x, I'm going to plug in negative 2. So what's 5 times negative 2? Negative 10. Negative 10 minus 3, they're two negative numbers. So we're going to combine them to get another bigger negative number. Okay, we're going to try f of negative 1. You should be following along with me and hopefully trying to beat me. Okay, if you're able to keep up with the speed that I'm doing, that's pretty good. Negative 5 minus 3, that's two negative numbers, so it's going to be another negative number, 5, 6, 7, 8. Okay, so when x is equal to negative 1, y is equal to negative 8. F of 0, you guys can do f of 0. That one's easy. When x is equal to 0, y is equal to -3. Okay, we're getting to the other side. We're getting to the positive numbers. We're going to plug in positive 1 wherever you see an x. So we have 5 minus 3 gives you 2. I want you to complete the rest of the table and plot the points. So f of 2, when you plug in 2 into the equation, you end up getting 10 minus 3, which gives you 7. And then the last one, hopefully you guys already beat me to it. F of 3 means 5 times 3 minus 3 gives you 15 minus 3, which just turns into 12. You're going to plot the points on that graph. Tell me what type of function is this. Okay, hopefully you plotted the points as well. My marker got stuck in my earring. Big hoop earrings, woo! Okay, so when you plug in these ordered pairs from your table, -2 and -13 didn't fit, and 3, +12 didn't fit. So I plotted -1, -8, 0, -3, 1, 2, and 2, 7. When you connect the dots, you end up getting a straight line. So what type of function is this? This is a linear function. From now on, I'm going to write fn. Fn just means function. Okay, so let's go to the next page. Like I said, my page may not look exactly like yours because I'm going to edit yours to fit on one sheet of paper. Alright, so it says using the table of values, find the following. Find f of -3. So it's saying when x is equal to -3, y, or another word for that is f of x, or f of -3 is equal to, and that's our question, okay? So when I look at my x values, when is x equal to -3? X is equal to -3 here, and my y value, or my output, is 2. So f of -3 is 2. You're going to try the same thing with b, f of 20. So you're going to look at your x values, 0, 9, 8, -3, 2, -5, 20. I found f of 20. And my output, or my y value, is 0. So when x is equal to 20, y is equal to 0. And this is just some random function. It's just giving us a table of values. So we don't know the function. We're just trying to find it using the table. This is actually really simple and kind of fun. When x is equal to 8, I'm going to look for 8 in my x coordinates. I find it here. What's my y coordinate, or my output, is going to be 4. Okay, go ahead and try f of -1. Were you tempted to say f of -1 is equal to 0? That is not correct, because there is no -1 here. And I know you saw it here, but this is another way to say f of x is y. So this is my output value. This is my input value. So since my input value is -1, but it's not on our table of x values, we don't know what it is, so we're just going to leave that blank. Okay, now we're going to switch gears a little bit, okay? So instead of using our input values to find our output values, we're going to do the opposite. It says if f of x is equal to 9, so in other words, if my output is equal to 9, what is my input? So if the output is 9, you're going to look for 9 here under our y values. I'm going to put a rectangle around it. So what is x? So x is equal to 2 when f of x is equal to 9. Does that make sense? I hope so. Let's try the next one. If f of x is equal to 4. So this is saying if my output is 4, what is my input? So we're going to look for 4 here under the y values, and I end up getting 9. So x is equal to 9 when, sorry about that, when f of x is equal to